Hi students, welcome back to another video. Today we'll be looking at Amaths Chapter 6, Binomial Theorem. Okay, in this very short video, I will teach you how to interpret the notation n factorial as well as solving some problems involving factorials. Alright, so this is a very short video. Before I start, can I get all of you to take out your writing materials and your notes, right? And please annotate together with me along this video. Alright, so for the first thing we will learn today, right, is to understand what does this notation n factorial means. Okay, so we have an n with an exclamation mark. Alright, so we read this as n factorial. Alright, so if I have a number, for example 6 with an exclamation mark, this would be read as 6 factorial. Okay, so what is the meaning of a factorial, right? So if you were to look over here, right, n factorial is defined to be this very long and scary looking equation over here. Alright, it is not as difficult as you think. Alright, so basically n factorial just means that you start off with n, alright, and you multiply each preceding term, which is one lesser than the other, all the way until you obtain the number 1. Alright, so what does this mean? Okay, so let's use a numerical example to better understand this. So if I'm looking at the number 5 factorial, okay, so what I will do is I will start off with the number 5, okay, and the preceding term, which is 1 lesser than 5, 4. Okay, I'm going to multiply these numbers, 3, 2, and finally 1. Alright, so this is what 5 factorial means. Okay, so similarly, if I have 7 factorial, I start off with 7 and I multiply each preceding term, which is 1 lesser, all the way until I obtain 1. Okay, and this can be evaluated using your calculator. Alright, so if you were to look at your calculator, right, let me clear this. Right, so you can first press 7 and then next you can press shift, and if you were to look at the exclamation mark, okay, on top of x power negative 1, right, you should be able to obtain your answer. So in this case, the value of 7 factorial is 5040. Alright. Alright, so there's another equation that we see over here. Okay, why is n factorial equals to n multiplied by n minus 1 factorial? Okay, the reason is simple. Because n factorial can be written as n multiplied by n minus 1 multiplied by n minus 2 multiplied by all the way until 1. And I hope you notice that these blue bracket terms give us n minus 1 factorial. Okay, so therefore, another way of writing n factorial is just n multiplied by n minus 1 factorial. Okay, so this is what the question, or rather the notes is saying. Alright, so let's try the first example. Evaluate 11 factorial over 8 factorial. Okay, so this is a simple question. So by applying the definition of factorials, 11 factorial is just 11 times 10 times 8 times 9 times 8 times all the way until 1. Likewise, 8 factorial is just 8 times 7 times 6 times all the way until 1. Right? Then you should see that the highlighted blue terms are basically 8 factorial. They are equal in value. So what I can do is these terms can be cancelled. Alright? So that leaves me with 11 times 10 times 9. And if you were to evaluate this, 11 times 10 times 9, that gives you 990. Okay, part B. Simplify n factorial over n plus 1 factorial. Okay, so likewise, applying the definition, Okay, same for n plus 1 factorial. Okay, you should notice that n minus 1 all the way to 1 has appeared in the denominator as well. Therefore, I can cancel these terms. Okay, so what other term do you observe that appears in both numerator and denominator? Do you notice n appears as well? Right, so you can cancel these like terms, right? So the numerator would just be 1 over n plus 1. Alright, so that's example 1. Now let's look at the next part over here. Okay, the next concept, we have something that looks like this. We read this as n choose r. Okay, so if I have 7 on the top, 3 at the bottom, I will read this as 7 choose 3. Okay, so the notes over here did mention that another way of writing n choose r can be given by this symbol over here. Okay, so I can write it as 7 with a capital C and 3 at the bottom right corner. So these two means the same thing. Alright, so one thing you need to note, okay, is that the number on top must always be bigger or equals to the number below. Alright, and the none of these numbers should be negative. All of these numbers should be positive. Okay, so that's something for you to take note as well. Alright, so there's a definition for n choose r. N choose r is given by n factorial over r factorial multiplied by n minus r factorial. Okay, so this is a formula. Okay, so it is just the way it is. Okay, we need to know how to apply this formula. Alright. Okay, so how do I apply this formula? Okay, so the larger number on top is n, the smaller number below is r. Okay, so as you can see, 8 choose 2, applying the formula 8 factorial over 2 factorial multiplied by the difference of these numbers factorial. Okay, so likewise, based on my understanding of what 8 factorial is, I'll write down the expression on the numerator. Likewise for the denominator. 8 minus 2 is 6 factorial, so 6 times 5 times 4 all the way to 1. And like just now, I noticed these two terms cancel each other out. Okay, so that leaves me with 8 times 7 divided by 2 factorial. And using the calculator, I would be able to obtain 28. Alright, so you can see for yourself. Okay, example B would be exactly the same. Alright, and I will just leave my answer like that because this is a relatively large number. Okay, so let's look at try it 2, example 2, right? Evaluate 9 choose 4. So applying the formula, right? 9 factorial over 4 factorial multiplied by 9 minus 4 factorial. Okay, so this will be 9 factorial over 4 factorial times 5 factorial. Okay, 9 factorial is 9 times 8 times 7 times 6 times 5 all the way until 1. And notice that 5 factorial is the same. 5 times 4 times 3 all the way until 1. So I do notice that these two terms are exactly identical. So I can cancel them out. So my numerator would be left with 9 times 8 times 7 times 6 over 4 factorial. Okay, so I'm just going to work it out. 9 times 8 times 7 times 6 over 4 factorial. So that will be 126. Okay. Part B. Show that 15 choose 3 can be given to be this expression. Okay, so 15 choose 3, again 15 factorial over 3 factorial times 15 minus 3 factorial. So that would be 15 factorial over 3 factorial times 12 factorial. Okay, so 15 times 14 times 13 times 12 all the way until 1. 3 factorial would multiply by 12 times 11 times 10 times all the way until 1. So these two terms, again, exactly identical. Cancel them out. Okay, this leaves me with 15 times 14 times 13 over 3 factorial, which is what I am required to show. Okay, so something interesting, I want you to take note over here. I'm not sure if you see a pattern. Okay, so if I have 9 choose 4, for example, do you notice that the denominator is the factorial of the smaller number? Okay, same thing, 15 choose 3, the denominator of the final answer is the factorial of the smaller number. So take a look at the purple highlighting. Okay, and if the number in the smaller number in this case is 4, for example, how many terms do I see in the numerator? 1, 2, 3, 4. Oh, seems like a coincidence, right? Okay, let's see if it is the same for part B. So if I see that the smaller number is 3, I would expect that based on the same pattern, there will be 3 terms in the numerator starting from 15. So let's check. 15, 14, 13. 1 term, 2 term, 3 terms. Oops. May not be a coincidence, right? So this is 3 terms. So this over here is 4 terms. Right? So do you think I can simplify this n choose r into a simpler formula? Okay, so maybe if I have something like 7 choose 4, okay, I can, based on the same pattern, deduce that denominator would be something like 4 factorial, right? And then I would expect 4 terms in the numerator, starting from the number 7. So this will be 7 times 6 times 5 times 4. Okay, so this is a very useful shortcut for us to simplify and choose R. Okay, so without further ado, okay, please read these examples yourself. Okay, I'm going to try out the last word example for this video. Okay, I have equation that says that n choose 3 is equals to 5 times of n choose 1. Okay, so n must be greater than 3 in this case, right? So by writing out the definition of n choose r, okay, just now I said that if the smaller number here is 3, denominator will be 3 factorial, and my numerator in the fraction will have 3 terms. Do you see that? So I start off with the letter n, and each preceding term is one lesser than the other. Okay, so what I can do now is, okay, noticing that there are n on both sides, I can divide n on both sides. So I can divide by n, divide by n. And that is okay because n is greater than 3, n is not equals to 0. So n cannot be 0. So we won't end up with a situation where we are dividing by 0. Okay, so this leaves us with n minus 1 times n minus 2 over 3 factorial equals to 5n. Equals to 5. Okay, so what I can do is I can multiply both sides by 3 factorial. So that will be 5 times 3 factorial, 30. N minus 1 times n minus 2 equals to 30. Expand. Okay. subtract 30 on both sides. Okay, and if I were to factorize, I should get something like that. -7 plus 4 is -3. Okay, so n minus 7 equals to 0, or n plus 4 equals to 0. So this means that n equals to 7 or n equals to -4. Okay, so since n is greater than 3, we require n to be the number 7. So the positive integer n in this case is 7. Alright.